Section 6.3, modeling data with a line of best fit. So what we're going to do is we're going to determine the linear function that best fits a set of data and use the function to solve problems. So here is a scatter plot. A scatter plot means we just take the data that we have and we collect them. And this is grade versus absences. So this is how often kids are absent, and this is their grade. And you can see there's a relationship. The more a kid is absent, the less their grade is, or the less the grade is, the more absent they are. So describe the characteristics of a polynomial function that might be used to model. So if we had a line, it might look something like this. That line kind of represents that data, and I just roughly drew that. There's a more mathematical way to do that. But if we looked at this line, we could see it's linear. We'd see that there would be a y-intercept somewhere up here. So if a kid had, let's say that's around 17 or 18 absences, they'd probably fail the class, and a kid with 0 absences gets 100. Okay, and that might be not all kids, right? Some kids with 0 absences get about 80. It's probably, you know, that slope isn't quite right. Probably that's a little better to the best fit. Yeah, because I don't want going around saying 0 absences 100%, but often less absences means a higher grade. So that describes it, and that's what we're going to be doing. We're going to come up with the function, so y equals mx plus b, and then it allows us to interpolate and extrapolate. So interpolate means take values within, extrapolate means takes values beyond, and that's what we're going to do. So here's the example. Matt buys t-shirts from a company that prints art on t-shirts and then resells them. When buying the t-shirts, the price Matt must pay is related to the size of the order. 5 of Matt's past orders can be listed below. Matt has misplaced the information from his supplier about price discounts on bulk orders. He would like to get the price per shirt below $1.50. Use technology to create a scatter plot. So what I've done is I've opened up Microsoft Excel and I've put in the information. Now what I'm going to do is I have to highlight, I have to go to Insert, and I'm going to insert a scatter plot. So here is my information. Now there's something I want to do. I want to put the linear trend line. And what I do is I go to Trendline and I say linear trend line, and that adds a line right there. 1, 2, 3, 4 points. Did I erase a point? 1, 2, 3, 4, 5. I did erase something. Let's see what I erased. 740, 169, 463, 51, 463, 200, 520, 200, 520, 700, 195. I forgot 500 and 325. Let's just add that in. 500 and 325. I must have erased it. Okay, so now I'm going to re-put that in. I'm going to go, remember I go to Insert, Scatter, and there's my plot. And then I go to Layout, Format, Layout, Trendline, and I go to a linear trend line. I want to know that equation, so I go to More Trendline Options, and I say that I want to display the equation on the chart. That's really important. Okay, so now I can see what that equation is. It's y equals negative 0.006x plus 6.5. So that means that it gives me my y-intercept of 6.5 and it gives me a negative slope. That makes sense. The more shirts that I buy, the less the cost is. Okay. Now what the question asks us is it says, what do the slope mean? We already did that. Use a linear regression function. Oh, no, we can talk more about the slope here. So the minimum cost per shirt is $6.50. Okay, then it goes down 0.65 cents for each additional shirt that you buy. Okay, now it says we need the function to extrapolate. So extrapolate means going beyond the chart. We're going to use the function to extrapolate. So just a reminder, that function was y equals negative 0.00, I forgot, 0065x plus 6.5. 006. Okay, so what do we need to achieve the price of $1.50 per shirt? How many do we need to buy? Okay, so I put $1.50. Oh, 6.5 x plus 6.5. I subtract 6.5 or 65 cents from, sorry, $6.50 from both sides. I get negative $5 equals negative 0.0065x. I divide both sides by negative 0.0065. If I got out a calculator, I would see that x is equal to 769 and change. So that means that I need to order, because we always have to round up. We can't have 0.23 of a shirt. We would need to order 770 shirts to get that discount. So even though the graph that we did was continuous, this should be a discrete graph because we can only buy single t-shirts. I can't buy 3.5 t-shirts. I can't buy 769.2 t-shirts. Okay, so that's where domain and range really come into play. So you're going to be using Excel a lot. Just remember how to find those. Remember we highlighted, we went insert, scatter, and then we went to the layout and we went trend line. We inserted a linear trend line because it looked like things were in a line, and then more trend line options. We had to make sure we had display equation on chart. Okay, so those are a couple of the things that you're going to have to remember. Of course, in your textbook, it summarizes some information. A scatter plot is useful when looking for trends in a given set of data. If the points seem to follow a linear trend, then there may be a linear relationship between the independent and the dependent. If the points on a scatter plot follow a linear trend, technology can be used to determine the and graph the equation. Technology uses linear regression to determine the line of best fit. Linear regression results in an equation that balances the points in the scatter plot on both sides of the line. A line of best fit can be used to predict values that are not recorded or plotted. Predictions can be made by reading values from the line of best fit on a scatter plot or by using the equation in the line of best fit. Here's a little side note. If you're in physics and you're plotting data and you need to do a line of best fit, plot it on Excel and get your line of best fit, and you will impress your physics teacher very much. Or maybe they've taught you that already.